So we're given a graph that shows resistance against light intensity for an LDR, and we're given a circuit as well. So here is our circuit. We have 9 volts across the variable resistor and across the LDR combined. And we have a voltmeter across the variable resistor. What else can we note from this? So we have the resistances in kilo ohms, light intensity is in lux. Okay, so first part, a student increased the resistance of the variable resistor whilst the light intensity was constant. Okay, so the resistance of the variable resistor, this is going up. So resistance goes up, and the resistance of the LDR, I think it said the light intensity remains constant. Yep, so then the resistance of the LDR will remain constant. So this doesn't change. And the question is asking us to see what happens, or explain what happens to the reading on the voltmeter. Okay, so we have 2 components in series, the variable resistor and the LDR, and they split the 9 volts. And the 9 volts, which is a fixed amount of voltage, that 9 volts is split in the same ratio as resistance, which is the case for resistors in series. So if the resistance of the variable resistor goes up, it then gets a greater share of that 9 volts, and the resistance of the LDR will get less voltage as its resistance is not changing. Okay, so let's write that down. So on to part B. So the variable resistor is set at a resistance of 4.5 kilo ohms. So the resistance of the variable resistor is 4.5 kilo ohms. And we're trying to determine the light intensity when the potential difference is 2.5 volts. So the voltage across the variable resistor is 2.5 volts. And because these 2 components are in series and they get 9 volts, therefore the voltage across the LDR must be 6.5 volts, as the 2 voltages will add up to make 9 volts. So we know that the voltage across the LDR would be 6.5 volts. And then to work out we're trying to work out the light intensity. To work out the light intensity, we're going to have to use the graph. So we have to know what the resistance is. We can then read off the graph and then figure out what the light intensity would be. To work out the resistance, we have to use ratios. So we know that voltage splits in the same ratio as resistance. That means that 6.5 to 2.5 is the same ratio as 4.5 kilo ohms to whatever the resistance of the LDR is. And then we can use fractions. We can say the resistance of the LDR divided by 4.5 is equal to 6.5 divided by 2.5. And then if we rearrange this for the resistance of the LDR, so we times this by 4.5. So 6.5 over 2.5 times 4.5, that gives us 11.7. And if you remember that the 4.5 is in kilo ohms, this resistance here will also be in kilo ohms. So now we have the resistance, 11.7 kilo ohms. We can then look back at the graph and then read off that value of resistance to get the light intensity. So if I zoom in, 11.7 is about here somewhere. We go across, we get to about there. That's kind of halfway in between these 2 lines. And this is an interval of 100. There's 10 mini intervals there. So each of those steps is 10. Therefore, this or these two must be 180 and 190. So the value that we have must be 185. And the unit was lux. So our answer would be 185 lux.